Today we're starting Unit 5, and this lesson is on roots and radical expressions. Specifically, this is when we are simplifying square roots, cube roots, fourth roots, whatever the case may be. Quick refresher, when you are simplifying a square root, if you had a number such as the square root of 4, hopefully you would all tell me the answer is 2. But if I gave you a number such as the square root of 12, you would break this apart to the largest square factor of 4 times 3. From there, you would indicate that the square root of 4 is 2, and you would simplify this to 2 times the square root of 3. We just spent quite a bit of time doing this in the last unit, so today's lesson is kind of a review. Of course, we add to it, but it is something that we've already been talking about this year. Because of that, I do kind of skip through the notes a little bit. If you have any questions, you need to see anything done out more than what you see in the video, just shoot me an email. I'll make you a new video, or we can meet one-on-one and answer the questions that you might have.
So there is one helpful thing that I usually do when I am simplifying any radical expression, and I usually make a list of perfect squares, perfect cubes, perfect fourth roots if it's applicable. We won't really be doing that many fourth roots, so if you guys just focus on square roots and cube roots, you'll be pretty good for this section. Before I do that, let's take a look at the key parts of a radical, so this part right here. You have, change to blue, you have the radical sign, which is this symbol. You should all be familiar with that. You're familiar with square roots, hopefully. Besides from the radical sign, you have what we call the index. Now the index is a little number that goes right here, so where I have highlighted in green. When you don't see an index, so if I gave you something like this, over there on the side, right here. If I gave you the square root of 4, the index is 2, but we don't write the index 2. It's just assumed to be there. If you don't see an index, then the index is 2. It's assumed. It's kind of like we don't write an exponent of 1 on every number. That would be a lot of wasted time. Same thing here. We just don't write that. So we can erase that index of 2. All right, so the index is the little number. And then underneath the square root, cube root, whatever symbol, so underneath the radical sign, is what we call the radicand. So it's a number that you are simplifying. All right, the first example set is finding roots. So this is just looking to see if you can determine each real number root for each problem. And this is where you might want to start making a list of perfect cubes, perfect squares, whatever will be helpful. And what I mean by a list is perfect squares are numbers, the answer to the number that you multiply by itself. So for example, 1 times 1 is 1. That's a perfect square. 2 times 2 is 4. That's a perfect square. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. And this list would continue. We're going to do the same thing with perfect cubes. So 1 cubed, or 1 times 1 times 1, is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed, 3 times 3 times 3, that's 27. 4 cubed, 4 times 4 times 4, that's 64. 5 cubed is 125. And this list continues. So when you're looking for a real root, you're looking to see, let's jump down to number 1 here. You're looking to see, okay, we're looking for a cube root, and we have -8 as our radicand. So can we rewrite the radicand as a perfect cube? Meaning, is there any number that you can multiply by itself 3 times that equals -8? And the answer to that would be yes, you have -2. -2 times -2 times -2 would give you -8 underneath the radical sign. And then when you simplify that, just one of them simplifies. So your answer would just be -2. If you have an odd index, you can have negative numbers underneath the radicand, like number 1 or number 2 here. But if you have an even index, like number 3, the index on number 3 is 4. If you have an even index, you cannot have a negative number underneath the radical sign. It never works out. And the reason for that is, take a look at number 4. The index is 4, so we need to know, is there a number multiplied by itself 4 times that's going to equal negative 1? And that would be no. The answer to that would be no, because negative 1 times negative 1 times negative 1 times negative 1 would be positive 1, and then positive 1 times positive 1 times positive 1 times positive 1 would also be positive 1. So no matter which way you look at it, they have to all be identical. You can't mix and match signs. So either your two options are negative 1 times negative 1 times negative 1 times negative 1. That still comes out to positive 1. Or 1 times 1 times 1 times 1, and that comes out to positive 1. So of your only two choices, you cannot end up with this as your answer. And therefore, there is no number raised to the 4th power that equals negative 1. Okay, when you're simplifying expressions, you want to take a look at what the index is, and then you want to, I'm going to say this for lack of better term, but you want to make groups that match that number. So if we take number 1 here and we break it down, we have the square root of 36 times x to the 6th, and we make groups of 2. 36 can be 6 squared. That's 2 values of 6. And then x squared can be x squared times x squared times x squared. Add those up, you would have x to the 6th. So we just broke it apart into 3 groups of 2. If your index is 2, you break it down into groups of 2. Then when you simplify it and only one value comes out. So the square root of 6 squared is 6. The square root of x squared is x squared is x, and x squared is x. Simplify that to 6x cubed. Same thing for a cube root. Number 3, we have the cube root of 27 times x to the 6th. So break it down into groups of 3. 27 can be rewritten as 3 cubed. And x to the 6th could be 2 groups of 3. X cubed times x cubed. When you simplify it, only 1 comes out. So the cube root of 3 cubed is 3. The cube root of x cubed is x. And the cube root of x cubed is x, giving you x squared. Now sometimes when you simplify, it doesn't work out perfect, or you still have something left over underneath the radical sign. If that's the case, then you just leave it under the radical sign, and that happens a lot. It actually happens more often than perfect numbers. If we look at number 5, we have 2 times the square root of 108 times x to the 4th times y to the 4th. And you can see that I have this note. It says 108 is not a perfect square, but does 108 have any perfect square factors? So I'm going to scroll up a little bit to our list right here of perfect squares. So we want to know, are any of those numbers that I just highlighted a factor of 108? And you want to find the largest one. So of course you're probably going to recognize right away that 4 is a factor, but it is not the largest one. The largest factor is 36. Oops. Sorry about that. So 36 times 3 is going to give you 108. I put that right here. I'm going to change my highlighter to blue. 36 times 3 gives you 108. Then we still had x to the 4th times y to the 4th. So now that I broke that down to 36 times 3, you should think to yourself, is there any way to make groups of 2 from the numbers that I have? So you can only do that on some of these values. For example, 36 can be 6 squared, but you cannot break 3 down, so 3 is going to remain the same. X to the 4th can be 2 groups of 2, and y to the 4th can be 2 groups of 2. when you simplify this, we still have the 2 on the outside of the function, so that remains. 6 squared, or the square root of 6 squared, is 6. The 3 is going to remain underneath the radical sign. The square root of x squared is x. The square root of x squared is x. The square root of y squared is y. Square root of y squared is y. So the only thing that we could not simplify underneath that square root sign is the square root of 3, which remains as the square root of 3. And then for your final answer, you multiply anything you can together. So 2 times 6 is 12, x times x is x squared, y times y is y squared, and the square root of 3 will remain. Now that we've gone over the lesson 1 note sheet, or at least skimmed through it, I'm going to do out each one of the on your own problems individually. So starting with number 1, we have the square root, it's actually the negative square root of 16 times c to the 4th times d squared. So just remember that if you don't see an index, it is 2. Alright, so what we want to do here is we want to make groups of 2 if possible. Our negative sign remains on the outside. Underneath the radical sign, I can break 16 down to 4 squared. That's a group of 2. C to the 4th would be 2 groups of 2, so c squared times c squared. And d squared is already 1 group of 2, so we're going to leave that as d squared. Now let's simplify. So do we know what the square root of 4 squared is? If you have a square root in a perfect group of 2, then just one of them will come out. Don't forget this negative sign that I just wrote in there. I'll rewrite it again. So negative, the square root of 4 squared is 4. Oops. Then the square root of c squared is c. The square root of c squared again is c. And the square root of d squared is d. Multiply your common terms together. Negative 4 times c squared times d is your final answer. Number 2 is a cube root. We have the cube root of 8 times a to the 6th times b to the 12th. I'm going to rewrite any term that I can as a group of 3. I know I can rewrite 8 as 2 cubed. A to the 6th can be a cubed times a cubed, so 2 groups of 3. B to the 12th would be b cubed times b cubed times b cubed. 3 groups of 3. Sorry, 4 groups of 3. Just realized I said that. Okay, so now when you simplify, you can take out the cube root. Sorry, I forgot my 3 there. The cube root of 2 cubed would be 2. The cube root of a cubed is a times b times b times b times b. So your final answer is 2a squared times b to the 4th. All right, number 3, this one looks a little different because now we have an expression. Just remember from past content that we've learned, you cannot break this apart because there is an addition sign and the exponent is applied to the whole expression. So we have to look at that expression as one single piece. You cannot simplify each one individually. This is a square root. We don't see the little index of 2, but it does exist. So we have the square root of x squared plus 6 in parentheses raised to the power of 16. So we can actually break this down into 8 groups of 2. We have a total of 16 right here. So we can, again, simplify that to 8 groups of 2. If I write that all out, it's going to be quite long. We're going to have the square root of x squared plus 6 raised to the power of 2 times x squared plus 6 raised to the power of 2 times x squared plus 6 raised to the power of 2. And this list is going to continue forever. All right. It doesn't continue forever. It continues 8 times. You have a total of 8 factors. But hopefully you're recognizing a pattern here. So for every one factor, one of them comes out. If you have 8 of them, 8 groups of 2, for every group, one will come out. Therefore, you end up with a final answer of x squared plus 6 raised to the power of 8. You would have 8 groups of 2. So 1 would simplify from every group. That means you'd have 1 from each group of 8 for a total of 8. X squared plus 6 raised to the power of 8 would be your final answer. Okay, and the last example is a cube root of 27 times b to the 18th times c to the 12th. So we have the cube root. 27 is 3 cubed. B to the 18th, that is 6 groups of 3. And c to the 12th is 4 groups of 3. When you simplify this, you end up with 3 cubed, or the cube root of 3 cubed, which is 3. You have 6 values of b. And you have 4 values of c. 3 times b to the 6th times c to the 4th is your final answer.